Next is equality of surds. This is an advanced surds subtopic, and at this point it's only for students who take further math or advanced math. And this subtopic is very important in finding the square root of surds. For example, you can be asked to find the square root of a plus square root of y. Let's say, for example, you have a plus square root of y and you're asked to find the square root. This surds subtopic is very important in finding the square root of this surdic expression. Now, to understand this topic, we need to solve this question. And as noted earlier, it's just for further math students at this point. If you're doing math, you need not to concern yourself with this. We have given two surds, a plus square root of y and b plus square root of z. What conditions must be satisfied if the surd a, the first surd, plus square root of y is to be equal to b plus the square root of z? This question is not hard. First thing you're going to do is equate this surd to this surd. So you have it as a plus root y equals b plus root z. First, you collect like terms. A and b, let's say for example they are real values. This will be 2 and 3, and this will be root 2 and root 3. These are like terms. A and b are like terms. You take them to one side. Let's take them to the left and take this root y to the right. So you have a, then this b you should note has a positive sign in front of it. But taking the plus b over the equals sign turns to minus b. But standard in math, you say you subtract b from both sides. Equals, you have this plus root z. You can ignore the positive sign, just write root z or root z. Then this root y or square root of y owns this positive sign. So as it's going over the equals to sign, it turns to minus root y. So you have it as minus root y. Standard in math, you say you add minus root y to both sides, and the result is still same as saying plus root y crosses the equals to sign and turns to minus root y. So you have it as a minus b equals root z minus root y. On this side, these are rational numbers and these are irrational numbers. If you have problems with rational and irrational numbers, you can go to the fundamental math series in the playlist section and go to types of numbers and watch. Now, these are irrational numbers. Note, when we're talking about irrational numbers, not all square roots of numbers are irrational. Like for example, the square root of 4 will give you 2. So the square root of 4 is not irrational, but it is rational. But the square root of 2 gives you a decimal. The square root of 3 gives you a decimal. They are irrational numbers. These are irrational numbers and these are rational numbers. And both of them can only be equal to one another if a minus b equals 0 and root z minus root y equals 0. So let's just write it out. You have it as a minus b equals 0. This is just a term in math. You just have to equate what is on the left to 0 and also what is on the right to 0. So you have root z minus root y equals 0. For the first one, we have a minus b equals 0, and it can be a equals, this minus b crosses back the equals to sign and turns to plus b. Therefore, a equals b. Then for the second equation, which is root z or root z minus root y, you take the minus root y over the equals sign, it turns to plus root y. So you have it as root z equals root y, because the minus root y crosses and turns into plus root y. You have root z equals root y. We can therefore say z equals y. We can say the roots will cancel out, or you simply say you introduce square to both sides. Therefore, z equals y. That a equals b and z equals y, or y equals z and b equals a. Anyhow you like it, it's still saying the same thing. As said earlier, this is very important in finding the square root of surds. And also, this technique is used in partial fractions, another topic under further math. So what this is all saying, or what we've done on this side is saying is, for example, you have a plus root y equals b plus root z. And because a and b are constants, they don't have roots, you can say a equals b, and y is under a root and z is also under a root. You can just simply say root y equals root z, because both of them are under root. You can equate them to one another, and to break it down, you can further say y equals z. The roots can cancel out, or you simply say you introduce square to both sides. The square will cancel the square roots on both sides. Then you have y equals z. All this is simply saying A can be equals to B if they are the same, and we can say since y is in root and z is in root, we can also say y equals z or y equals z. It's right to note that we are able to equate A to B and y to z, because if you look at these two surds, one on the left and one on the right, you see that both of them have positives. It's not the case of one being positive and the other being negative. They are both positives, and also note both of them are in square root or in root 2, not that one is in root 2 and the other is in root 3. And note, both roots have a coefficient of 1. It's not written, but they have 1 in front of them. So these conditions are required before you can equate A to B in this case and Y to Z. We'll be able to tackle more questions or more advanced questions as we go into the root or square root of surds. It's not really hard, it's very easy.